Hello, everyone, and welcome to our February 2022 Astronomy Fundamentals presentation for the Naperville Astronomical Association. Thank you for joining us. We appreciate you guys joining us online. Obviously, we hope to get back in person soon. Tonight, as you're watching this, if you have any questions on Facebook, you can just put them in the comments section. Or you can email questions to questions@naperastro.org, and we will get those questions fed into Jim, our speaker tonight. So let's just jump right in. Tonight, our speaker is Jim Sweitzer. Jim is a Chicago native with a PhD in astrophysics, and he was the assistant director at the Adler for 13 years. And he's worked on about 24 planetariums across the globe. And tonight he's going to be giving us an introduction to the eVscope. So Jim, if you are there, we'll.
Hi, thanks, Jim. Yeah, I'm still here. Right. Well, thank you very much for the introduction, and thanks for the opportunity. It's a real privilege for me to be on your Naperville channel here and in doing this. I've enjoyed your talks that you do, and I really enjoy the club. I think it's one of the most amazing clubs around. So what I'm going to do is I'm going to go to share the screen now. Give me a second to get ready here on the right thing. Optimize for video, a couple settings here. Okay, and I think we'll be ready to go. How's that? Can you see that?
Looks good, Jim.
And you hear me fine? Okay.
Yep.
All right, thanks, Chris. Again, I really feel privileged to be able to speak in this group. I have tremendous respect for the Naperville Astronomical Association. Your programs are amazing. I've been very happy to have a member now for a couple of years. But tonight I'm going to talk about something I know a little bit about recently. We're going to talk about the eVscope. Here's the outline for tonight's talk. I'm going to give you a little bit of personal background on some of my motivations, because they're maybe not the same as a lot of people for these sorts of amateur adventures. I then go into a little bit about the technical basics for the people who want to see under the hood of the car for these scopes. Then I will actually take you through an operating basics, almost as if we went out, not tonight, but some other nights and short. In fact, I can do that. It just complicates. It's a little cold right now. Then I will take you through some of the images, things I've gotten with it. Almost all are mine, but I'll show you a couple other really interesting examples by others. And then I'm very interested in the programs, how they're used for outreach and also citizen science. And about halfway through, I know that Chris is going to field the questions. We'll take a break for questions right after the technical things. But Chris, go ahead and interrupt if there's a urgent question anytime. Then we'll do questions at the end. So let me talk a little bit about background and motivation, because I've got an unusual record in astronomy. And let me talk to you a little bit about that and my motivation. Okay, so I made a telescope mirror, like maybe some others did during the 1970s when I was in college one summer. I got the mirror almost finished, but then went off, finished college, went to graduate school, and wound up at the Adler Planetarium. And luckily, I think it was Jim Sievers and Dan Joyce helped me actually finish the mirror up, get it polished up in the optical shop at the Adler, but it never really made its way into a telescope because I was always distracted doing other things. But I have gone that far, enjoyed that. But, I've always lived either in a big city like Chicago, maybe not downtown, but in a city environment, or I've lived a number of years in New York City where I would have liked to have had a telescope to take on the roof. I actually lived in a 5th floor walk-up. I could have gone on the roof, but I didn't have one, and it just never really came together, although I'm deeply interested in using telescopes. Anyways, and my professional motivations are often, this is the type of client I've had recently. Last few years, I've worked on the Shanghai Astronomical Museum. It's the largest in the world. It's 14,000 square meter facility, but in the back you can see there's two pretty good sized domes, a little ring shaped donut it's an observing camp for children. There's an observing deck on the top of the museum. So places like this, I'm interested in how can they do astronomy, and this part is near the edge of Shanghai, but it's at least as light polluted as we are here. So I've been motivated in my amateur astronomy efforts to think about the sorts of telescopes I could use that are easy. And this is my equipment, basically, my other equipment here, basically. I'm interested in things that are useful for astronomy education, in particular outreach. I like things that are capable under light polluted in urban and suburban skies. I'd love to get further out. I'd love to have a big job, boy, I really would. But I know I'm realistic, I can't make it out. And a lot of the people I work with want things for near at hand. I'm interested in things that are easy for novices to use. And, I do have a degree in astrophysics, so I didn't even learn anything about the moon or planets in the university. So I'm a little more biased to clusters and nebulae and the galaxy in particular. And lately, citizen science is really interesting, at least in some of my work world. So things that work well for citizen science. So that's why when in 2018, I found out about the eVscope, I got pretty interested. I had two friends on the West Coast who had seen it in operation, a prototype that was still kind of under a Kickstarter campaign. And I was able to purchase mine basically at the Kickstarter prices. They're relatively expensive. But even then, that was expensive, but it was, I had it checked out and I thought it was a good idea. It's made by Unistellar, a French company. There are other, I call it smart telescopes. It's hard to know exactly what to call these things in some ways because they really are astronomical cameras that have a go-to feature with them. So sometimes I'll call it a smart telescope. Vaonis makes Stellina and now Vespera. These are the little ones on the left. And Vaonis, also interestingly, a French company, they call them observing stations. So anyways, the language hasn't totally caught up to them, but basically they're astronomical cameras. This fellow on the right too, I think, I don't know how to pronounce his name, Cuiv, the Lazy Geek. You can find him online. I don't know, maybe you've seen him. It's quite engaging. But he shows you how for, I don't know if you can still do it for $1,000, you can put one together yourself, something very similar to Vaonis things. So I think we're going to see more of these. And but let me talk to you about the eVscope. These are based on enabling technologies like anything, and I'm sure a lot of you know about these, probably more than I do. The first, of course, is the imaging sensor. The eVscope uses an IMX224 by Sony. These are CMOS, right? So they're not really technically CCDs. They're in color, and the electronics work a little differently, but they're really great low-level light cameras. The eVscope also has an onboard Raspberry Pi computer of some sort. I don't know if it's this one, but there's, it's smart in the sense that there's a lot going on board the telescope. And the smartphone is used to control them, but basically just to control. The scope is doing almost everything else on board. And in my mind, another enabling technology is that the software that does the plate solving, which is the term people use to talk about having this thing find out where it's pointed at the sky and tracking the sky, that software, and then also the image stacking and processing software that's on the Raspberry Pi, those are all absolutely essential for making this thing work. So the eVscope requires a smartphone or a tablet, and you can control it with a tablet. Like I've got my iPad with it to the right. And basically whatever you do, whether you use a tablet or smartphone, it has to have GPS, because for this telescope to work, it needs to know where it is and exactly what time it is. And so the phone provides that. You connect with Wi-Fi to the scope, but you can also connect 9 other Wi-Fi watchers, if you will. So if you come out with me and I'm at the observing site in Naperville, if you put the app on your phone, you can connect as a watcher, basically. Okay. But the thing that makes it really cool is it does image stacking in real time. This is an ad video from Unistellar of eVscope 1, which is the one I have, which has an eyepiece, and it's to show you what this looks like when you look through the eyepiece and the stacking goes on. Of course, the Orion Nebula M42 is extremely bright, so it goes very, very quickly. Anyway, but that's, so the eVscope 1 is the one I'm going to talk about. It's the one I have. There's a model called the Equinox, which doesn't have the eyepiece. Talk about that in a minute. And then there's now an you can't buy an eVscope 1 anymore, but you can buy an eVscope 2, which has a slightly upgraded technologies. So let's look at the technical basics quickly here. So here's the scope. It's a Newtonian design, a 4.5-inch mirror. You can see in the middle, it's f4 ratio. It's relatively fast and small. And then up at the secondary, at the focal point, is where the imaging sensor is located. And this sensor is about 6 millimeters diagonally across. It gives you 1.27 megapixels. Here's the list of the technical specs. It's on an alt-az mounting. So that means also technically it's easy to use. You just basically point it at the sky and it figures out within a minute or so how the sky is working. But it also means that the image is rotating as you're taking longer images. And so that affects how the stacking works. The field of view is about, I think, 27 by 37 arc minutes on that bigger, if you use the full chip. If you use, you'll often see me with round masks on things, and then I'm about 27 arc minutes across. And that's fixed. You can't vary that. But it's designed for a lot of these deep space objects, and just barely, in my case, gets the moon. In fact, the moon isn't, it's a little too big for it. The resolution of this thing is about 1.7 arc second per pixel, which, of course, the seeing that I experience is never anywhere close to that. So it's usually pretty good. The images can be, now, the current version of the software come out as 4.9 megapixel. They do a process, I only know a little bit about it, called drizzling, where they take the 1 megabyte thing and they slew it around and get higher resolution out. As I said, also smartphone app contains a 5,000 object catalog in the phone, but you can put coordinates in, and it accesses also the citizen science projects. So you're not really limited to those, but that's pretty easy and convenient. You'll see how it is. And it's also capable of adding 9 additional observers with Wi-Fi connections. One nice thing is there's really no wires. Once you're up and you're charged up, there's no wires to trip over, have unplug, or whatever. And so I've sometimes, maybe you've seen me a couple of times out at your observing site, I brought my iPad and I just make an iPad an observer. I find you'll see that again later. I have pictures of using it. There's some more technical specs. It again has an onboard computer that does the Wi-Fi connection. It does the plate solving. It does autonomous field detection. You just basically, it's got to be in focus or close to focus. You point it at the sky and tell it, like a dog, to hunt, and it will find where it's pointed and start tracking. Then you select an object, and it will then, as any go-to telescope, then at that point, and I get about, it's accurate to within an arc minute. It's pretty good. Unless I don't have the tripod leveled properly, it will usually nail things, and then it'll track. In the image processing it does on board, and this is all I know. I think there's actually other things going on, but I don't know enough about those to even ask the right questions of Unistellar. But it does, it takes these images, it rotates them and stacks them for as long as the battery would hold out. And it stores them on the scope. It can store the frames in other ways too, but it stores them and also puts them straight out to your phone. When you're operating it, once you're acquired an object and you want to go deeper, you could go into enhanced mode, it's called, and it takes basically 4-second exposures indefinitely. And I think it's 4 seconds because that's the optimum size, time length before the rotating gets to be a little challenging. Magnitude limit, I get fainter than 16th magnitude routinely on a bright point source, like a star or quasar even. And I think you can easily get to 18th magnitude in a dark site. One of the big pluses is the weight, including the tripod. It's about a little over 19 pounds. So I usually am never too lazy. I can't pick it up and take it outside. Okay, so this is Eric Bangham's just showing you the eyepiece. Talk a little bit about the eyepiece. It's a little deceptive to call it that. It's really a micro OLED screen. Pretty high contrast, and you can't even really see the pixels, and it's relatively bright. So when you look in an eVscope, you see colors in more detail. It actually looks pretty good. It's kind of fun, actually, I think, and especially with star parties and so on. Some people like it. People like to just look at them on iPads and so on too, but these are kind of fun. It doesn't require dark adaptation either. So if you're dark adapted and you're out with me, don't stick your eye in this eyepiece. The eVscope 2 has a better optics, I think, in it, maybe a slightly better screen, but maybe a little easier to focus if necessary, but really the one does fine. And of course, this is not present in the Equinox model. You don't have an eyepiece. So you're going to see some pictures. Here's my observatory site, park, looking down back, and those people standing by the car down there in the alley, that's basically where I observe from down there, not from the gazebo. But there's a lot of trees, total trees around. I routinely measure sky brightness of 16.9, so I'm Boreal 9. I also have, I call, jokingly, at least from my family, I call it Mount Ridgeland Observatory. I'm routinely shooting through wires back there. It doesn't seem to, if there's a bright light on a wire, it's a problem, but I just go right through the wires. I also have to deal with 2 mercury vapor alley lights down in the alley, and an annoying apartment building down off to the south, which is exactly where I want to point at times with a sodium vapor light. But I seem to block them or get around them a little bit, so I do okay. You'll see my images. So down on the lower left is the backpack. I always carry it out in my backpack because I'm scared to death to drop the thing, especially in the dark. But I go out. I usually take it out and let it chill down so the mirrors cool, at least close to ambient temperature. That helps, but it's a small mirror, so it doesn't take too long. Then you have to level the tripod. There's a little bubble level on the tripod. It's not really too hard to do. I can do it in the dark. Once you get going, you get tracking, you really want to take the time to focus. And the focus scope, you can look through the eyepiece and do it, but the way to do it really accurately is to use the Botanoff mask. And I'm sure some used it on your scopes too. You put this mask on, you get this diffraction these 3 diffraction lines, and you get those to line up. There's a focus wheel on the back that you turn that moves the primary mirror in and out. I've got mine marked here, you can see, so that in case I bump it, at least I always know I'm close. I also have it marked, you can't see it, a little bit lower to the right. When I put a filter in, and I do use a filter now and then, the focus changes a good bit, so I usually put it over on that mark for the filter if I use a filter. So when you're up and running, once you get going, your focus, or even before then, the first thing you want to do when you're at ambient temperature is take a dark frame. The software needs to know what 0 dark is, and so that's how it does it. And there are hot pixels. Anybody who does astrophotography, I'm sure, runs into this. And in particular, in the hot weather, see them. Here's an example of M27. And here you can see some of my hot pixels. This is just a 96-second exposure, but you can see there's a couple of my hot pixels. And when I saw this, I said to myself, darn, I didn't take a dark frame. When you take a dark frame, it pretty much eliminates the hot pixels. So that's basically the technical things. Let me show you how it is to operate it. I'm going to show you now screen grabs of the app, which has just a number of screens. One thing you can do is in settings, you can set it for your type of location, namely whether your city, suburban, or countryside. And you can also, these yellow circles and quadrant, you can set your boundaries. I don't really worry much about this. This, I think, is useful maybe for a novice who wonders whether they can even see what they're looking at. I tend to go for things anyways. But if you, in my case, I would probably just set it for the eastern sky. That's all I can see. And I would put the bottom one up about 20, 25 degrees. Then you can see in the middle screen here, this is the basic settings screen. It has, across the bottom, has different icons for different modes of operation, but now we're in the user mode. And here you see the battery, how much storage is being used. There's an eyepiece focus helper, taking the dark frame, parking the scope is all here. Anyway, so this is, that's how you interact to get going. Then you flip all the way over to the left with the little scope. When you're going, this is what you see at first. So you'll have, you'll see stars. This is running at, I don't know what the frame rate is, about 1/30 of a second or better. And you're seeing the actual live. And on this screen here, I'll explain to you, there's the big round thing with the arrows. This is the joystick, the digital joystick, if you will. Below it to the right is something with a crosshair. That's what you use to get it to find out where it's at in the track. And then there's this eyeball kind of thing with a star above it. That's to when you want to go into enhanced mode. The eye thing, I don't know, that's if you want information about what you're looking at. Up at the top, there's a few other controls there. The one on the upper right brings you to certain settings if you need them. And then there's, of course, something to download. So you can download the pictures straight to your phone, or you've got another one there you can text them or email them to other people. And actually that I find useful, especially if I'm with friends or something. I found even if they're not watching directly on their phone, I send them the pictures right away. They love it. And they actually wind up sharing them. So I've actually used that a bit. Along the bottom of this, the menu too, there's a planet with stars. That's your object database. And there's a scholars cap. That's for some of the citizen science stuff. And then the thing with the picture and the little mountains, that's to get you to your picture database. So here's what it's like when you're in this explore mode. The scope will, based on your settings and the time and everything, it will give you suggestions for things to go for. Galaxies, nebulae, clusters, a lot of them. If you scroll down, give you stars, planets, and then you can also put in RA and DEC or ALT and azimuth if you like. And then if you go into the scholars cap settings there, these one really neat thing about the eVscope I found is the SETI Institute. This is in Mountain View, California. They're partners with Unistellar, and they provide a lot of these citizen science programs you can work on. So they help you with, you can participate in asteroid occultations, you can participate in measuring exoplanet transits, planetary defense, that's just anything that's coming really close, and comets. And so I'll show you some of the results of that. So here again, here's the screen when you're on live mode and tracking. When you're in that mode, you can also change the gain and the exposure time. Typically when it's on automatic, the gain is all relative anyways, but the exposure time is 5 milliseconds. So it's about a half a second. It's a half a second is what the chip is putting out. If you go into enhanced vision, when you're actually stacking images and all, you often usually just automatic, but you can go in and change the brightness and the background level too on your images it's stacking. I'm not sure exactly, it's just manipulating the light curve, I think. Okay, so it also allows you to digitally zoom. Okay, so you can, I mean, you're not gaining any more resolution than you have, but you can make the image look bigger. So, and that's just done gesturally on the cell phone screen. So here's an example of M51, and then I sort of zoom it out. Okay. So I'm going to take you now just to show you what it's like to observe. On the right of your screen, I just recorded a couple minutes of this, and you'll see what it's like here. I went to Orion. I just chose it off the menu. I could type it in, and it's now literally slewing over here. At this point, the scope was already tracking and focused already. So once I'm on that, then I can just go ahead and punch M42 or click the icon. You know, we'll go through this process. It takes about a minute. It goes over, and then I think it sort of checks to make sure it's in the right place. And then even when it brings the object into the field of view, it lets it track a little bit. I think that's just so it knows which way the tracking is going on. So here's Orion now with like the half-second exposures in the so-called live view. Orion it's a great object. It's wonderful in so many ways, but it's very bright, very, very bright. And to get the trapezium, you'd have to go in live mode because it's just so incredibly bright from the gain window. So now it's validated the go-to, and it's centered. And then at this point, I clicked the eyeball thing, and it's starting to do the stacking. And it will, in the bottom here, then show, you know, how many seconds. So now it's 8 seconds, and we'll just go a little ways here. So this is, so that I think the field of view is ideal for something like Orion, although it actually gets bigger than this. And you can see the colors already here. So it does relatively well with the colors. Anyways, we'll just go a little bit here. You'll start to see some changes, but if, anyway, the signal to noise improves. You know, this is the statistics on this. It's a square root of time. So when you get to a couple minutes, you're doing this awfully well. Here's Richard Berry took some images he loaned me to show too what it's like with 4, 48, 76 up to 243.6. It's like what, 40 minutes, right? No, I don't. So what happens in practice is once you get to about the 5 or 6 or 12 minute level, you know you're going to have to spend a lot of time to get much farther. And so especially here, if I were in a darker site, it might be a little different. Here's another example of M1, the Crab Nebula. So by 6 minutes, you're doing pretty well. And so it's not like you have to wait around a long time. And if you got people with you, like my impatient members of my family, they're satisfied relatively quickly and want me to go on and quit explaining too much. But anyway, so that's how that goes. anyways, let me take a break for questions. That's most of the technical things. Chris, if you have questions.
Yep, we got a couple here. So the first question posed by Eric Clays, does the image move around like it did in the video? So
Oh, in the first video,
yeah.
no.
Okay.
That's unistellar marketing. When the image is in there, it doesn't really move. If there's wind and the thing stops and restarts tracking, you might see a little bit, but no, it's really pretty steady. But it's rotating the whole time. If you do a long exposure, you can see at the edges of the frame that some of the earlier frames are going off. That's why I often just put it in the circular mask, because you won't see any of the rotating.
Okay. And my own question here, there was a setting on the very first setting tab you showed called visibility, like city, countryside, and something. Do you know what that does? It doesn't. There was another setting for exposure, but.
Right. No, that setting, those settings at the beginning that you're talking about, Chris, those are really for novices to not pitch to you in the menu things you're going to have trouble seeing. Okay. So that's not really changing any setting in the scope. That's changing the settings of the menu selection. Does that make sense?
So it's like a limiting
Yeah.
A magnitude limitation, basically? Like if you're in the city, you're only going to see so many stars and stuff.
Right. But, my experience, look, I'm in Bortle 9. Stars, which are, so it's fine bright point sources, I see down to 17th magnitude. So I think it's maybe more for the dark, the broader nebulae or something like the Horsehead or something like that. But, I found that I just go for the things anyways. I don't pay attention to that.
Okay. The next question again by Eric. Does the scope support flat frames?
Flat frames? Oh, I don't think, I know what you mean, flat frame. I don't know. I mean, I don't do any flat frames. Maybe they will in the future, but right now all I do is take a dark frame. This is a good question, because I do get sometimes gradients across my images, but those are, I think, due to the light pollution, because I know how they get set up, where the lights are and where I'm pointed. And I also know that when it's snowy out, when there's snow on the garage roofs and on the ground, I get reflected light in the scope. So I know what he's talking about, but at least there's no way I can get to doing flat frames.
Okay. And then this is by David Barkus. How close or far away from the telescope can the Wi-Fi observer be?
A good question. I haven't tested that, but I think it's, I've gone to the back of the house. I try not to get too far away, because about your neighborhood, my neighborhood is, not only are there skunks and coyotes, but there's strange characters drive up and down the alley. I'm afraid to get too far away, but I have been easily 30 or 40 feet away and not been a problem. I listen to the people online talk about it, and a lot of people, especially the Canadians or in Finland, people in the cold, they put it outside in the backyard and they go inside and they operate it from indoors. And some people have even used Wi-Fi extenders to get even farther. So, but I'm getting 30 feet, no problem.
Okay. Brian Leshin asks, how long does the battery charge last?
The battery charge. They quote 4 hours. I think that's the technical spec. But I've never come close to running out. Because of my situation, I couldn't track anything for 4 hours anyways. I'd run into the trees, or I'd freeze to death or fall asleep. So I've not had a problem. I think when it's cold, the spec for cold is -10 Celsius. I forgot what that is. The battery life drops off a bit, but frankly, I've had no problems. But you can also plug another battery in. But I have a huge lithium battery and a cord. You can put that in. You can also charge your phone back off it too. So practically speaking, I haven't had any trouble. if I were to go out, I'd love to go on like a Messier marathon or something. I'd probably bring a big battery and just plug it in and not have to worry about it.
Okay. Anthony Harris asked, what type of warranty comes with the scope?
Ah, I know, because I just ran out of it. It's 2 years. There's these clips on the legs when you're using it. And the other night I was out when it was really, really cold, and I had my big heavy boots on. I stepped on one of the clips and broke it. And they told me, oh, you're out of warranty. But they sold me another one very reasonably. So yeah, I think it's 2 years.
Okay. We have the most questions I've ever seen, Jim. So we're going to just kind of plow through these here.
Sure.
Let's see. The next one is by Mike McLaughlin. How does the optical quality compare with the best? For example, Q-star quarter wave optics, 1/8 wave.
Boy, I wish I could tell you. I don't know how to calibrate it against that. So I have a Maksudov, a beautiful little 4-inch Questar. Not Questar, I'm sorry, a Celestron that I love, but I don't compare it. So it's hard for me to say. I know that you have to worry about collimating it. I've only had to collimate it once, although maybe I should go back and check. So collimating is not hard, but you have to keep it collimated. Focusing is important. If you're not in focus, it's going to make a big difference. But you know, between the resolution, it's hard to say. It's operating. I think the optics are perfectly fine for this resolution. If you were to go to higher resolution, I don't think the seeing could take it anyways. And I know too much to be dangerous, too little to be dangerous on this. And I think if the pixels were much smaller, the sampling would be oversampled, and that might not be great. So for the things we look at, it seems just fine.
Okay. I've got a long one. From Andrew Mills. I'm going to try to summarize it a little bit. He's going to be doing a presentation to kids during the day. So does it have a day mode so that they can entice their parents to come back for the evening but night?
That's a good question. Well, people do look at the sun with it. Okay, they put like a Mylar filter on the end, and you can look at sunspots. So I don't know that it's not technically, it's not literally designed for that. So I don't know how it tracks. So they have to just track it on their own. I think Vaonis is coming up with one that will track the sun in the daytime, at least white light. So you could use them for the sun, but no, I mean but it shares with Zoom really nicely. So if the daytime program is on the other side of the Earth, not a problem.
Okay. Next one by Brian. Oh, sorry, the questions are really rolling in. Brian Leshin, is there a desktop version of the application?
No, not that. No, I think there are people who found ways to emulate the app on the desktop, but no, they don't have a desktop version.
Okay. Ellen Steiner asks, she wears glasses. Can you focus the eyepiece well enough to use the scope without your glasses?
Oh yeah, I mean, it's right. Basically, you're looking at a little video screen and you've got a magnifier. That's what's going on there. And if you saw my settings, they have a thing where you can set it up to, it puts a reticle in there so you can look at it. And what I tend to do if I'm going to be out with the public is I will set it. I wear progressives, they're crazy, but I will go to my furthest distance and I will set it for that, which is like as if you have perfect eyesight, Affinity. And then that generally works for everybody and they don't have to refocus. But if it's just myself and I really want to get into it with the eyepiece, I will take my glasses off and I will focus it to work that way.
Okay. And the next two questions, I'm kind of combining them because I think you've already kind of answered them. Let's see. Oops, I lost them. Can you add an outboard battery or a power station? It sounds like you did.
Yes.
Okay.
Yes.
And then
Yeah.
the other question, I think, which you just answered was the coldest ambient temperature the scope can operate in.
Well, that's the spec is -10°C. And somebody do the math. It's like 18 degrees Fahrenheit, something like that. But I've gone out colder. You know, I used to work in Antarctic Observatory too. So personally, I can take colder temperatures. I think it's a matter of the battery and so on. And some people have gone out relatively cold, and it's mostly a battery issue.
Okay. And let me just check. And I'm thinking that's, let me refresh my system here real quick. And I think that's all the comments we have at this time. So
Okay.
if you got more, press on.
Good. Great. Thanks. And also, I want to just also respond to Anthony's question about the warranty. I think it is a major issue to worry about service for the long haul. At this point, the Unistellar is very responsive, but they've been extremely responsive and quite good. So I've only got good points for them, and other people have had the same experience. But you know, if there's a problem with them, there'll be a problem in the future. Anyways, let me go on and show you some things, then we can take even more questions at the end. I'm going to show you a gallery of images from here, from Oak Park. And for the most part, I might have taken some of them and tweaked them sometimes in Lightroom a little bit just to take a gradient out, but not for the most part. These are pretty much what you see is what you get. These ones I'm really proud of. These I took last month. I caught the James Webb Telescope on the way out. I was really thrilled with this. So on the right, you can see this little line. This is a 24-minute exposure, and the telescope moved about 4 or 5 arc minutes. So the Unistellar people, they're connected with the JPL ephemeris. They give you really precise ephemeris for objects like this. And so bang, I nailed it, and I got to see it on the 2nd, and then back again on the 3rd, on the 10th again. It's still not quite at L2, but getting pretty close. And it varies because the telescope was rocking or turning a little bit. It's a light shield. So this is the part of the use of this thing that I'm really happy with and personally interested in working more on. Someone had asked about filters. I'll just show you. There's a filter holder that I use. And this is an Optolong L Pro, seems to be the one that's the most popular for people. It's there on the left, and the transmission curve is shown here. So it transmits, the hydrogen lines past 650 nanometers, and then the hydrogen beta and the oxygen lines down around 500. And it's also blocks the mercury and the sodium. Now in my backyard, I actually do have mercury and sodium lights back there, so it helps a bit, especially with nebulae. But it's of no help with broadband objects like galaxies. In fact, it makes them worse. So like any other filter, it has its use. I have an oxygen filter. I actually have an H beta filter. I haven't used the H beta filter, but I have used the oxygen filter, and that will really nail, especially planetary nebula. So here's some of my pictures. Speaking of planetary nebula, there's full frame image like of M27, the dumbbell, and then there's the moon in live mode. And you can see the field of view is just a little too small for the moon. The eVscope 2 has a bigger field of view and gets the moon. I've done planets. Okay, so here's what Saturn looks like. I have to change the gain to get it to look right. It works. People have shown it to like it, but it's not like you can see with some of the scopes I've seen at your observatory, that's for sure. Here I've zoomed up by a little over 7 times. And then to get the moons, I have to change the gain. But if I change the gain and overexpose the planet, here I got 3 of the moons on this particular night. Outer planets are easy because the telescope's like a hunting dog. It'll find them pretty easily. So Uranus, Neptune, and of course Pluto. So it'll find Pluto. You have to, of course, With Pluto, you need a finding chart or take an image over a couple days to make sure you got it. But I usually make a finding chart so I know if I'm looking at Pluto. So anyways, planetary nebulae look great and in color. It's kind of fine. You can see the center of stars on a lot of them. Here's M71. This is actually a small globular cluster, I believe. And it stars, especially in my location, look really great because they'll pierce through the light pollution. And just so you orient you to these things, if you look along the bottom, it's got in this case, the Messier number. It's got the amount of time I've been on the object. And then, of course, those are my coordinates and the date this was taken. So here's M39, which is another open cluster. This one it's actually bigger than this field of view. This is just the central region. But this is only a 36-second exposure. So clusters look really good at it. And you can see this, the diffraction spikes, people asking about the optical quality. And of course, it's imaging, so that's it's going to the bright stars are going to occupy a certain amount of real estate. Open clusters are really good. Part of the reason I showed M67 and M26 here is because on the left, with M67 was an older version of the software back in 2020, and by 2021 they had gone to the drizzling thing, so the resolution of the final image is about double what it was before. So I mean, times I like the old signal noise, but you get higher resolution this other way. Globular clusters, it's great with. I just wish I lived far enough south to see Omega Centauri. It looks terrific in one of these, but these aren't too shabby. M22, you can see a little bit of a gradient on the left that I had to take up because it's low in Sagittarius. It's near that my wonderful neighbor's parking lot. Spiral galaxies, it does fine. Of course, M52 is the poster. M51, I mean, is a poster child. That's a 54-minute. That's about as long as I've gone on anything. That was last March. The sombrero on the right, slightly higher surface brightness. That's only a 5-minute image. That's typical length I might go. M87, I had a friend come by, says, "Can you see a black hole?" I said, "No, but I can see a jet." Now this is zoomed in. Maybe you can start to see the jet. And again, this is here. I was not even an optimum night or anything, but you could just barely make out at about 2 o'clock or 1:30 the jet. Nebulae, it's great. I love it on nebulae. In fact, the first thing I looked at was M1 Crab Nebula. That's without a filter. On the right, that's with the Optolong Pro filter. But it still looks pretty darn good. It's just that, again, Eagle Nebula is a low declination, so I'm shooting over more light pollution, and also the filter helps give a little extra edge to get through that. Here's some really good pictures, not ones I took. These are taken at maybe Bortle Force skies or whatever. I don't know. Mike Edwards did M101 and then identify the H2 regions in it. I kind of like this. And then all these two, this one and the next one, definitely had some offline processing. So typically they use different things, but Photoshop or Lightroom. There's a couple other ones. I'm not sure of all of them. Here's one that I just got from Denis Cotin near Belgium. This is almost a 3-hour. Now he took actually 20 separate images over the 3 hours and then took those 20 separate images back in and stacked them. Not sure why he did it, but he knows more about Photoshop than I do. I'm sorry, he's a Bortle 6. So that he used Photoshop to stack those, do the secondary stacking, and Lightroom to adjust the colors. And then he used a program, maybe you guys know it, called Photo Affinity to bring some of those down. So this is pushed about as far as I've seen this stuff get pushed. I was really happy. One of the goals, this COVID time, right? So I was lucky. I had this like a lot of things I could look at. Okay. And so one of my projects over the last year or so was to get all the Messier objects. So I did. I got all 110 Messier objects from my back alley that you just saw there. There may be one or two I took from your observatory site where I needed to get lower in the south. Pretty much all of them are there. It goes from, and I've organized these. This was sort of a revelation to me. I organized them by distance, not Messier number. So the closest thing is the little center of the Pleiades off to the right, 430 light years. Then it goes off to 82 million light years at the top. And what I found was interesting here, sorry, I like to teach astronomy, but the first 4 rows, the first 40 are all nebulae and open clusters, basically. There's a double star or something thrown in there too. When you go to the next 3 rows, from rows 5 to 7, except for some Sagittarius star field, these are all globular clusters. So there's like about 29 of those. And then from rows 8 to 11, there's M31 to the, just to the left, up in the upper left a little bit, all the way to the end. The slip up is M109 at 82 million light years. So I call this Cosmic Chicago. So I made this into a poster. Actually, it was Rick Gehring asked me, he said, "Are you going to make a poster?" So I said, "Oh, okay." So I did. So Rick has one of these, I know. So I was proud of this. It was kind of fun. So now I'm looking for other things to do. A lot of these could be a lot better, but I was just thrilled to be able to get them from here. So let me talk at the end here quickly about some of the outreach and the citizen science programs that go on with this scope. It's pretty useful for this sort of thing. So I remember I mentioned connecting with an iPad here. Colleague Paul Derby's in Virginia. He's got his eVscope in the back and he has his iPad running this stuff. And I found that I've done that a couple of times. It's really nice because people will stand around and talk about what they're seeing. So that works pretty well. So public star parties, it's nice. It's great on Zoom because you share over the digital phone link. And so I've done maybe 5 or 6 events where I've zoomed into and often on the other side of the planet. I've done some into France. I've done a couple into 3, I think, into Siberia. And even to some friends. I had friends in New York or in Connecticut who wanted to see it. I said, well, look, get on your computer or your phone, or if you can get on Zoom, we can go observe. I think it will be big for astrotourism, where people go to remote locations because this thing is extremely portable. I've been talking to people who do aurora tours. This thing is perfect for that because in the night when the aurora doesn't perform, you can pull it out and use it, and your guests can actually be indoors. And I've talked with work with a friend who uses it in his Astronomy 101 courses out in the Northwest. And his students, he takes them out, he gives them star charts, they look at the sky, and then they look through the eVscope, they look up there and they say, "That's there." This is the phrase that his students often say. So I find it's a really powerful way to do deep sky objects with the public. It's fast. As I said, international Zoom. Here's a colleague of mine, Pavel Nikiforov, in Irkutsk Astronomical Observatory or whatever. He just got one. I worked with him to get one. And this is his first light picture, his M1, just 2 minutes in, but he's got the tripod way down. Let me just say that it was a crappy night out there. First of all, it was minus 11 Fahrenheit. They were sitting in the car most of the time. And I know that the transparency wasn't really great, but you can do programs like this remotely quite easily. There's a lot of citizen science programs. This is where people take data and contribute to science. And there are programs in exoplanets, comets, asteroids, satellites now a little bit. Supernovas, this thing will, see supernova. There's, supernovas in these relatively nearby galaxies. There's about 7,000 scopes in use currently and about 10% of the users have at least been in one citizen science campaign, 1,000 observations. And the SETI Institute is crucial for this. And they have graduate students who massage the data. For example, here's results from a recent paper where they did asteroid occultation. The asteroid blocks a star and they take the timings. So what you do is you go out and they'll alert you to go out, and you put your scope in record mode. And basically it's recording at a relatively high frame rate, FITS images that it stores that then get uploaded back to the SETI Institute where they do the final analysis. Here's a couple other ones that are kind of where there's citizen science. On the right is one with the exoplanet transit. This type of flux change is not hard for this telescope, and so they get a bunch of people to team up on that. They'll send the timing out. Comets, I participated in doing, this is Comet, not Comet Leonard, another one earlier. And then up on the left is this near-Earth asteroid that came by on the 18th, right? And so here's someone's image of that streaking by. Another one that I was trying to get it, but I couldn't. I tried. They thought it was Elon Musk's second rocket stages. This is the one that's going to plow into the moon on March 4th. I was not able to get it from here in Oak Park. I tried, but Skaichi Fuki in Japan caught it. And so that's kind of fun. I kind of like this sort of thing. Oh, anyways, I was going to, before we go to questions, today's Galileo's birthday, right? The 15th. That's just a coincidence. Anybody who knows me knows I'm a kind of a Galileo fanatic. I just wrote a book where I write letters to Galileo. But I think it's worth, after seeing such a complicated and sophisticated telescope, to go back and think about the roots. This is Galileo's the house he lived in Padua, in Italy, where he did his major observations in 1609 and 1610. And he would have observed from the second, or they would have called the first floor, but the second floor. This house is still there in Padua, faces to the south. So he's looking out those windows, basically. I've been to the museum in Florence, and they have this mounting for a Galilean scope. They're not sure whether it was his, but they think he would use something similar to this. It's also Altaz, as you could see. They, of course, have telescopes. The telescopes in that ivory thing made in the 19th century is his first objective lens. And of course, he didn't have a chip in the computers to record the data, but Galileo was an artist, or he was trained as an artist too, so he's very, very good. So his images came out really great. And I just think it's his birthday. We owe so much to him, even if we have these amazing tools these days that, we're all following in his footsteps. So anyways, that's basically all I have to say. I'm happy to take a lot more questions or whatever you want to talk about. Thank you.
Okay, we will start with the questions. There's a bunch that already flew in. So we'll start off with Christy Alston. How do you collimate and how do you take dark frames?
Okay, so Christy, to take a dark frame, I usually do that first thing is when I know the telescope is cooled down. I've got it you turn it on, you put the cap on you put the aperture cap on, and you tell it to take a dark frame, and it takes about a minute or two, and it takes its dark frame. To collimate, it's a different issue, and honestly, I've only had to do it. I did it once after I received it when I thought maybe it was off a little bit. I don't drive around, I don't bang it around, so it's not going to get out of collimation, I don't think, too easily. But to collimate it, you throw it totally out of focus. Then you see the crosshair, you see the secondary supports, the crosshair, because you see an image of those on the mirror. I don't know technically everything's going on. And if that's not, you then turn the two screws in the back until you center that, till you center the the secondary support, if you will.
Okay. I'm not quite sure. I think this is more of a comment that you could just simply take your darks and flats and save them externally and then integrate them later. So I'm gonna move on to Ellen Steiner's question. Is what you see in the eyepiece the same as what you see on the phone or iPad?
Yes, exactly. Right. Pretty much, although this eyepiece, it's round, okay? So you see a round image, but it's the same. And if you zoom up on your, a little bit on your phone, it'll zoom up in the eyepiece too.
Okay, and I think you already answered this question as well, because you gave us some actual examples. Mike McLaughlin was, could the scope track a comet?
Can it track?
A
Can
comet.
it track? Yes.
Comet.
You just need the coordinates, that's all. And so there is a setting for, I mean, you can go in and there are comets, and the SETI Institute people maintain the ephemeris for that, and that's all available on your phone. So if there's a comet out, it'll be on your list of ones to go to.
Okay, it's my own question here. Can you turn off the drizzle feature? Because I'm assuming that'll kind of reduce your battery life a little bit.
Yeah, I don't know if it reduces. I'm not sure, Chris. I think it's a good question. No, I don't know how to. I don't think that's available at the moment.
Okay. Steve Segarian asks, are you able to superimpose a reticle over the field of view?
No. No, you'd have to do it. And it's not in the software.
Okay. Okay. And I think you've kind of answered this one too. What format can you save the files in? You mentioned FITS already, but can you also do TIFF, other file formats?
Right. No, we don't know. Actually, we don't have a lot. There's a couple answers to this question. First of all, I think in the scope native, they're saved as some sort of FITS files thing, but you don't have access to those. Those, you can get them. Everything you do, I generally upload to the SETI Institute. So all my individual frames are all stored there. I can actually get those back from them. I have to request them. It's a little, for me at the moment, it's not that important for me to get to the FITS files, which is what you'd want to do any real quantitative thing with them. No, they're saved as not JPEGs. What's the other? It's the uncompressed PNGs.
Okay.
So they're like 8-bit PNGs when they come off of this thing. So that's okay, but they work, and for the imaging things I want to do, they're fine. But I know Richard Berry, who's doing photometry with this thing, he gets the FITS images back, and I think it won't be long before we have more direct access to the FITS images.
Okay, and that question was by Eric Clays. So next one is again by Steve Segarian. Do they offer an upgrade path for larger imaging chips or larger pixel arrays?
No, you have to buy the new scope. Basically, they currently no. I think they discontinued the 1, and now they have the 2. And the 2 is higher resolution, slightly better and other things, but it's a lot more expensive. So I don't, yeah. Currently, no. This group has been doing this for about 3 years, so we'll see what happens. I know that people would like to have bigger scopes and all, but I think it defeats some of this thing is pretty optimized to be in this little package.
Okay, and I think we kind of covered this at the beginning, but maybe you could expand on it. Steve Segarian asks again, are there any do-it-yourself open source projects that are similar to this scope?
There's this Queeve guy, I think that's how you pronounce it. It's in that one slide. He has a DIY, you can watch it online. He buys a small refractor and an astronomical mount and a camera and gets it to work. I was pretty well, I thought. It's really kind of fun, but you have to be able to write or manipulate the code, and it's a little more involved, a lot more involved. Maybe I might be interested in doing that, but actually I'm kind of lazy. And so the threshold for this is I really want to go out and see this thing or that thing, and I just pick it up and go out.
Okay. Let me go to the questions. We have comments of very informative presentation. Ellen Steiner wanted you to go back to the Bagnov mask image because she couldn't discern what was in focus and what was out of focus. I think those were actually all in focus because the diffraction spikes were all properly aligned. But if you want to go back to your presentation and show that slide again, she would appreciate that.
See if I can. Hang on. Yeah, that's it's close in that one. I have to say, I looked at it, I wondered, should I show this or not? Because it seems to be so close. But let me just pop this back up. Right, so in focus, it's right in the center. I don't know if what you're, in my screen, I can see it. And it's a little to the right, the center line on the right one, and a little to the left on the other one. What happens in practice is you don't want to use a real bright star, then it's too bright, or you just turn the gain. You turn the gain down as much as you can so you can really see those lines. This gain is up a little high, and you zoom in, and you get used to doing it. Yeah, there we go. You line those three things up. That one is a little far to the right. The other one here, the center is a little far to the left. Yeah, so this is real close. Usually it's further out than this, but it's pretty close.
Okay. All right, so I believe this might be our last comment or question. What is the most urgent and engaging citizen science project that middle school students could do with the scope? That was a question by Kevin Ichabod.
For middle school, that's a really good question. You're asking the wrong person because I used to design and make programs. So I would start to think of things I wanted them to do and figure out. I think let's take a look at this list quickly. So, I think the thing that would be the exoplanets is interesting, but it has to be massaged by someone, okay? The comets are pretty direct. You can go out and you can see the comets. I think the asteroids are interesting too because you can actually see and track the asteroids. So I don't know. That's a good question for middle school. The other thing I would personally think of doing, I almost wanted to make a class like this for a college I was at. I would like middle school students to do imaging, to actually manipulate the images. So I would probably give them, have them pick an object that we know is going to be in the sky, and then take them through the process of where is this object, what is it like, and then bring it into class and have some sort of tools, computers, so they could actually work on images. I've worked on programs in Mars student imaging for just this age group, where we actually manipulate images from the Mars Reconnaissance Orbiter or the Themis instrument. I think there's a lot of potential because this does deep sky objects nicely to get them in, because the images are graphic, have them work with real images and get to know, come out of it using Photoshop too. Let's put this one up here too. This is if people want to drill even further out. I'll take more questions as long as you want. But this guy by the name of Walczek in Germany has a nice page where he goes through lots and lots of more details. And of course, there are Facebook groups that related to the eVscope or Unistellar.
Okay, well, I know as soon as I say this, and a question will come in right after I say this, but it doesn't look like we have any more questions at this time, Jim.
Okay, well, here's my email address is here on this slide. So if people really want to get in touch with me, and I'm on the Facebook groups. There's one for international, there's an American there's a French one, and so on.
Are you on the clubsgroup.io?
Yes,
Yeah.
exactly. For the club members, it's pretty straightforward. Yeah.
Okay. Well, Jim, thank you very much. This was very, very interesting. It's a pretty cool scope. I appreciate you talking to us tonight.
Yeah, well, I'm happy to. I'm just, it's a privilege to talk with you. I'm just really impressed with your club. So this is a real honor for me. So good luck. Hope the weather's good and you get nice, dark, clear skies.
Thank you, Jim. Have a nice evening. Thank you, everybody, for watching.
Bye-bye.